Friends, welcome back to Guru Baswa classes of class 10th grade. Class, I am going to discuss with you about new chapter which is very interesting and it will be continued for your 11th grade and 12th grade. Okay, that is chapter number 8, Introduction to Trigonometry. Yes, in this chapter we are going to discuss mainly about first we will discuss with introduction and important topic, that is trigonometric ratios of some specific angles, trigonometric ratios of complementary angles, and lastly trigonometric identities. Yes, are you ready? Yes, one of your friend is looking at the top. See here, he is looking from this position to top of the Qutub Minar. Okay, can the student find the height of the Qutub Minar without actually measuring it? The answer is yes. With the help of or by drawing the right angle triangle, we can find the height of the Qutub Minar easily by using trigonometric ratios. Understood? Yes. Then what are the uses of trigonometry? Trigonometry is used in navigation, ship navigation. It is used in GPS. It is used in astronomy. It is used in video games. It is used in constructions of buildings. It is used in flight engineering. It is used in marine biology. It is used in criminology and many more fields, etc. Okay. Yes, then let us understand the meaning of the word trigonometry. The word trigonometry is derived from the Greek words tri, meaning three, gon, meaning sides. That means three-sided figure, which is nothing but what? Triangle. Okay. Metron, meaning measurement. Yes. Then what is the definition of trigonometry then? Trigonometry. Trigonometry, it is that branch of mathematics which deals with the measurement of the sides and the angles of a triangle and the problems allied with an angles. Okay, or in other sense, trigonometry is the study of relationships between the sides and angles of a triangle. Understood? Yes, next we will move to trigonometric ratios. The ratios of the sides of a right triangle with respect to its acute angles are called trigonometric ratios of the angle. Okay, we will restrict our discussion to acute angles only. We have to consider right angle triangle and we have to restrict our discussion for acute angles. Understood? Yes. In a right angle triangle ABC, okay, this is a right angle triangle ABC, right angled at angle B. Angle of reference, we can consider it as angle A or angle C because these two are acute angles. Okay, the side opposite to is called a perpendicular. See here, if I considered angle of reference as angle A, then its opposite side is what here? BC. Okay, we call it as opposite side or perpendicular. The side adjacent to the acute angle. Okay, I considered here angle A, its adjacent side is AB. That one we call it as base or adjacent side. Okay, and the opposite to the right angle, the side opposite to the right angle, what we are seeing here, AC. Okay, for every right angle triangle, its opposite side will be the hypotenuse. Okay, that one I am writing here again. Angle of reference is equals to angle A I considered. Okay, then perpendicular will be side BC and base will be the side AB and hypotenuse will be side AC. Next we'll move to considering one right angle triangle and we will explain the trigonometric ratios. There are totally 6 trigonometric ratios are there. Let us, we will discuss here. See here, let angle BAC is equals to, I will consider it as theta, be an acute angle of a right angled triangle ABC. In right angle triangle ABC, let base is equals to AB, we will call it as X, denoted by the letter X. Perpendicular is equals to BC and denoted by the letter Y, and hypotenuse AC denoted by the letter R. Okay, we define the following ratios known as trigonometric ratios for angle theta. Okay, yes, sin theta is equals to, see here, first trigonometric ratio, that is sin theta is equals to perpendicular divided by hypotenuse, or opposite side divided by hypotenuse, that is equals to y divided by r, and is written as a sin theta. Next trigonometric ratio, that is cosine theta, is equals to base divided by hypotenuse, that is adjacent side divided by hypotenuse, which is equals to x divided by r, and is written as cos theta. Next, third one, trigonometric ratio, that is tangent theta. Tangent theta is equals to perpendicular, that is opposite side divided by adjacent, or perpendicular divided by base, which is equals to y divided by x, and written as tan theta. Next, fourth ratio, that is cosecant theta, is equals to hypotenuse divided by perpendicular. Okay, hypotenuse divided by perpendicular, which is equals to r divided by y, and is written as cosec theta. Okay, cosecant, it is the reciprocal of sin theta. Understood? Second, it is the reciprocal of cos theta. See here, hypotenuse divided by base. Okay, hypotenuse divided by base, that is r divided by x, and written as sec theta. Second may be written as sec theta, cosecant may be written as cosec theta, tangent theta may be written as tan theta, like that. Okay, last one trigonometric ratio, that is cotangent theta, which is equals to base divided by perpendicular, x divided by y, and written as cot theta. Okay, it is the reciprocal of tan theta. Understood? Important things or points you have to keep in mind. See here, note the symbol sin theta is used as an abbreviation for sine of angle theta. Okay, sin theta indicates what here? We can read it as sine of angle theta. Understood? Easily we will read it as sin theta. Understood? It is the sine of angle theta, but it is not the product of sine and theta separately. Sine separated from theta has no meaning. This interpretation follows for other trigonometric ratios also, that is cos theta, tangent, that is tan theta, cosec theta, sec theta. Understood? Yes. Next point. For the sake of convenience, we may write sin square theta, cos square theta, etc. in place of sin theta whole square, cos theta whole square, etc. respectively. Okay, see here, sin square theta is also same as sin theta whole square. We may write like that, but cosec theta is equals to sin theta whole raised to -1. Okay, sin theta whole raised to -1, which is not equals to, sin theta raised to -1 is not equals to sin inverse of theta. Understood? Because sin inverse of theta has different meaning, which will be discussed in higher classes. Next, important points. Some important points about trigonometric ratios are given below. First point, the trigonometric ratios are defined for an acute angle theta. If one of the trigonometric ratios of an acute angle is known, then the remaining trigonometric ratios of that angle can be easily determined. Next point, the value of each of the trigonometric ratios of an angle does not depend on the size of the triangle. Okay, see here, the value of the trigonometric ratio of an angle does not depend on the size of the triangle. It only depends on the angle. Next point, the values of the trigonometric ratios of an angle do not vary with the lengths of the sides of the triangle if the angle remains the same. See here, the values of the trigonometric ratios of an angle do not vary with the lengths of the sides of the triangle if the angle remains the same. Okay, next point, As we know that the hypotenuse is the longest side in a right angled triangle, so the value of sin theta or cos theta is always less than 1. Okay, if you consider sin theta value, it will be always less than 1, and cos theta is also less than 1, or in particular equals to 1. Okay, whereas the value of sec theta or cosec theta is always greater than or equals to 1. Therefore, the value of sec theta or cosec theta is always greater than or equals to 1. Next, we will discuss about relationship between trigonometric ratios. Okay, relations between trigonometric ratios. First one we will discuss here. Since trigonometric ratios sin theta, cos theta and tan theta of an angle theta are very closely connected by relation, if any one of them is known, the other two can be easily calculated. Okay. From figure we have, this is the right angle triangle PQR, right angled at Q. Okay, and angle P we consider it as theta. Sin theta is equals to what we will get here, opposite side, that is QR divided by hypotenuse PR. Like that, cos theta is equals to adjacent side, that is PQ, or base divided by hypotenuse, that is PR. Last one, that is tan theta is equals to QR divided by PQ. Okay, opposite side divided by adjacent side, or perpendicular divided by base. Okay, now we will discuss about quotient relation. See here, tan theta is equals to perpendicular divided by base, or opposite side divided by adjacent side, that is QR divided by PQ. Tan theta is equals to QR divided by PR whole divided by PQ divided by PR. What we did here, we divided both numerator and denominator by PR. Okay, what we will get then? See here, QR divided by PR, it is nothing but what here? See here, QR divided by PR is nothing but what? Sin theta. Okay, whole divided by PQ divided by PR. PQ adjacent side divided by hypotenuse, it will be cos theta. Understood? Therefore, tan theta is equals to sin theta divided by cos theta. Keep it in mind. Next, second one, cot theta is equals to PQ divided by QR. Cot theta is equals to PQ divided by PR whole divided by QR divided by PR, dividing both numerator and denominator by RHS part. Okay, RHS part, numerator and denominator by PR. Yes. Next, reciprocal relations. We'll move to reciprocal relations. Relations between trigonometric ratios and their reciprocals. First one, sin theta is equals to 1 divided by cosec theta. Okay, or reciprocal of sin theta is equals to cosec theta. Next, cos theta is equals to 1 divided by sec theta, or reciprocal of cos theta is equals to sec theta. Tan theta is equals to 1 upon cot theta, or reciprocal of tan theta is equals to cot theta. These are the reciprocals relations between trigonometric ratios. And okay, next, note down, sin theta into cosec theta is equals to 1. Second point, cos theta into sec theta is equals to 1. Tan theta into cot theta is equals to 1. How we are getting this? Sin theta into cosec theta is equals to 1, cos theta into sec theta is equals to 1, tan theta into cot theta is equals to 1. I'll consider third one, that is tan theta into cot theta, which is equals to, see here, tan theta is nothing but what? Sin theta divided by cos theta, into cot theta is nothing but what? Cos theta divided by sin theta. See here, sin theta and denominator sin theta will get cancelled, cos theta and denominator cos theta will get cancelled. What we left with? 1. Therefore, sin theta into cosec theta, like that you can solve that one. Understood? Sin theta into cosec theta is equals to 1, we will get. Cos theta into sec theta is equals to 1, we will get. And tan theta into cot theta is equals to 1 we are getting. Given that tan A is equals to 4 by 3, find the other trigonometric ratios of the angle A. Okay. Yes. Solution. Draw a right angle triangle ABC. So here this is the right angle triangle ABC. Right angled at B. I consider angle of reference as A here because they mentioned tan A. Okay. Yes. We know that tan A is equals to BC divided by AB. Why? Because tan A is equals to opposite side, that is perpendicular, divided by adjacent side, that is base. Therefore, BC divided by AB. Already given here, what they have given here? 4 by 3. That means what? BC is equals to 4 and AB is equals to 3. Therefore, if BC is equals to 4K, then AB is equals to 3K, where K is a positive number. I'll rewrite it as AB is equals to 3K here and BC is equals to 4K. Now, by using the Pythagoras theorem, we have what we are having here? Hypotenuse square is equals to sum of the squares of base plus square of perpendicular. Understood? That is AC square is equals to AB square plus BC square. Substitute the value of AB here, that is AB is equals to 3K and its square is 3K whole square plus BC square, that is 4K whole square. 3K square is 9K square and 4K square is 16K square. Sum of these two will be equals to 25K square. We have to find the side AC. Therefore, transpose square root to RHS part means it will become square root of 25K whole square. It may be written as square root of 5K whole square. Then square root and square root will get cancelled. What we left with? We left with 5K. Therefore, AC is equals to 5K. Hypotenuse is equals to 5K. Now, we can write all the trigonometric ratios using their definitions. Yes, sin A is equals to opposite side, that is BC, divided by hypotenuse AC. Substitute the value of BC and AC, we will get 4K divided by 5K and KK will get cancelled, left with 4 by 5. Therefore, sin A is equals to 4 by 5. Cos A is equals to side, that is base divided by hypotenuse, AB divided by AC, which is equals to 3K divided by 5K and we left with 3 by 5. Therefore, cos A is equals to 3 by 5. Next, cot A is equals to 1 upon tan A. Reciprocal of tan A is equals to cot A. Yes, cot A is equals to what we will get? That is 3 by 4, because 1 divided by 4 by 3. 3 will move to numerator. It will become 3 by 4. Like that, cosec A is equals to 1 upon sin A. Sin A already what we are having here? 4 by 5. Therefore, 1 divided by 4 by 5. It is nothing but what? 5 by 4. And lastly, sec A is equals to 1 upon cos A, which is equals to 5 by 3. Okay.